The strongest El Niño in 155 years. 0,000 Entesauern seconds. There's a strip of ocean along the equator in the middle of the Pacific, roughly halfway between Hawaii and South America, that nobody lives on. There are 0.0888 seconds. No cities and no coastline. Nothing out there but water and a line of repasted, message collapsed. Orchestrated balanced synthesis of reference material with contemporary research data. Orchestrated balanced synthesis of reference material with contemporary research data. Video topic: the strongest El Niño in 155 years. What it means for your winter. On July 21st, 2026, Hurricane Boris crawled ashore on the southern coast of Mexico and killed 4 people before it even had time to organize into anything the record books would remember. It caused at least $81 million in damage, flattened palm groves, and flooded coastal towns that had barely finished rebuilding from the last storm season. On paper, Boris was minor, a footnote, the kind of storm that gets a headline for 2 days and then disappears from the news cycle entirely. But Boris did not happen in isolation, and that is the part almost nobody reported. In the same stretch of days, the Eastern Pacific produced Hurricane Genevieve and Super Typhoon Dolphin, both Category 5 systems, spinning at the same time, in an ocean basin that is now running at the most active early pace ever recorded. Meanwhile, 3,000 miles east, across the Gulf and up the Atlantic seaboard, hurricane season had gone eerily, unnaturally quiet. Tropical cyclone formation had stalled out completely over the Caribbean. Forecasters at the Climate Prediction Center wrote in the last week of July that development was unlikely for the foreseeable future. 2 oceans, same summer, same planet. One shut down entirely, the other one breaking records. That is not a coincidence, and it is not random noise in the weather. It is the fingerprint of something enormous building in the middle of the Pacific, something that has never been observed at this scale in 155 years of recorded history, and something that emergency planners across the southern United States are already treating as the defining weather story of the next 12 months, months before a single drop of winter rain has fallen. Here is the number driving all of it. There is a strip of open ocean along the equator, roughly halfway between Hawaii and South America, where nobody lives and nothing floats except a scattering of research buoys. As of the second week of August 2026, the water in that stretch of ocean was running nearly a full degree above normal and climbing fast. 14 separate forecasting models, feeding a combined ensemble of 667 individual simulation runs, now agree that by the time this event peaks between November and January, that patch of ocean will be sitting at roughly 6 degrees Celsius above its historical average. If that forecast holds, it would not just break the existing record for the strongest El Niño ever measured, it would obliterate it, and the confidence behind that number has only grown since midsummer. In July, NOAA's Climate Prediction Center put the odds of this event ranking among the strongest on record at 81%. By its August update, that number had climbed to 90%. Separately, NOAA has said there is now roughly a 70% chance this becomes the strongest El Niño since consistent record-keeping began in 1950. This is the part I want you to sit with before we go any further, because it is the reason emergency managers, insurance actuaries, and disaster relief agencies across multiple continents have started acting in August on a forecast for events that will not arrive until winter. A record number on a thermometer floating in empty ocean does not, by itself, mean a record disaster shows up on your street. What it means is that for the next several months, the odds of certain kinds of weather shift dramatically in certain places and drop just as dramatically in others. And that shift is now large enough and confident enough that NOAA has already rewritten its hurricane outlook around it, insurance markets are repricing risk around it, and international relief agencies have opened emergency funding appeals around it months before winter has even started. Let's talk about what that number actually measures, because El Niño is one of those phrases everyone has heard for decades, and almost nobody has had explained to them properly. The region scientists watch is called the Niño 3, 4 zone. It is a rectangle of open tropical Pacific, straddling the equator, running from roughly the international date line eastward toward the coast of South America. Forecasters take the average sea surface temperature inside that rectangle and compare it against the long-term seasonal normal. When that anomaly sits at 0.5 degree Celsius above normal for several consecutive months, that officially qualifies as an El Niño. Cross 2 full degrees Celsius, and you are in very strong territory, the tier that gets called informally a Super El Niño. Only 3 events since 1950 have ever reached that threshold at their peak. 1982-83, which topped out around 2 degrees, 1997-98, which reached about 4 to 2. 75 degrees depending on which index you use, and 2015-16, the current record holder, which peaked around 6 to 2. 75 degrees. Reconstructions of the historical records stretch even further back. And the 1877-78 event, rebuilt from ship logs and early instrument readings, comes in at roughly the same ceiling, around 7 degrees. Read those numbers together. Across a century and a half, across every documented super El Niño anyone has ever measured, the ceiling has essentially been the same ceiling, hovering in a tight band just below 8 degrees. Nothing has ever meaningfully broken through it. And the median forecast for this winter is 6. That is not a new record by 1/10 of a degree. That is a projected record that clears the old ceiling by nearly a full degree, in a measurement where a full degree is an enormous, almost unprecedented margin. Some analysts, including climate researcher Zeke Hausfather, who compiled the 14-model consensus in mid-July, put the probability of this event breaking the all-time record at around 91% using the raw historical comparison. Correcting for the fact that the entire planet's oceans have warmed over the past century, which can exaggerate how unusual a given anomaly looks against an old baseline, that probability drops to a still remarkable 77%. Either way, this is forecast to be the strongest event ever documented, and the confidence behind that forecast, this far out, is itself historically unusual. Now, here's the mechanism, in plain terms, because understanding how this actually works is what lets you tell the difference between a genuine warning sign and hype. Under ordinary conditions, trade winds blow steadily from east to west across the equatorial Pacific, driven by the planet's rotation and the temperature gradient between the equator and the poles. Those winds push on the ocean surface, and over the width of an entire ocean basin, that steady push adds up. Warm surface water gets dragged westward and piles up around Indonesia, Papua New Guinea, and northern Australia, forming what oceanographers call the Western Pacific Warm Pool, a genuine physical mound of water sitting measurably higher than sea level off the coast of Peru. On the eastern side, the water that gets dragged away has to be replaced, and it gets replaced from below. Cold, nutrient-rich water rises up from the deep ocean along the South American coast in a process called upwelling. That cold water feeds plankton, the plankton feed anchoveta, and the anchoveta feed one of the largest commercial fisheries on Earth. That is the normal, stable state of the tropical Pacific. El Niño begins when the trade winds weaken. Without that steady push holding it in place, the mound of warm water in the west starts sliding back east, not as a visible wave, but as a slow subsurface bulge of warm water called a Kelvin wave, traveling thousands of miles over a matter of weeks. When that warm water arrives in the east, it pushes down the boundary between the warm surface layer and the cold water underneath, a layer called the thermocline. Push that boundary deep enough, and the upwelling along the South American coast can no longer reach cold water at all. What comes up instead is warm water, and the eastern Pacific heats up. NOAA's own July diagnostic discussion described exactly this happening in exactly these terms, noting that a Kelvin wave had deepened the thermocline in the eastern Pacific, and that a large reservoir of unusually warm subsurface water, built up over the preceding months, was continuing to feed the surface warming. And then the system does the thing that makes it so difficult to stop once it starts. It begins reinforcing itself. Warmer water in the central and eastern Pacific means more evaporation and more thunderstorm activity over ocean that used to be too cool to support much convection at all. That shift in thunderstorm activity drags the atmospheric circulation eastward with it. The shifted circulation weakens the trade winds even further. Weaker winds let more warm water slide east. More warm water fuels more thunderstorms. The ocean and the atmosphere lock together in a feedback loop, each one pushing the other in the same direction. And that loop tends to keep running until the reservoir of warm water feeding it is finally exhausted. This is why El Niño is not weather in the conventional sense. Weather changes over days. This is a coupled ocean atmosphere state that assembles over many months, holds for the better part of a year or more, and then slowly unwinds. And because thunderstorm activity over the tropical Pacific is one of the primary engines driving the planet's jet streams, relocating that activity by thousands of miles rearranges the steering currents for storm systems across an entire hemisphere. An ocean does not have to touch your city to change your weather. It only has to change where the heat goes into the sky above it. You do not have to take that mechanism on faith because a piece of it has already played out in the real world over the past 2 months, visible in exactly the way the textbook says it should be. Go back to the 2 oceans I mentioned at the start. NOAA's Atlantic hurricane outlook for this season calls for a 55% chance of below normal activity, with a forecast range of only 8 to 14 named storms and 3 to 6 hurricanes. Colorado State University's independent seasonal forecast, one of the oldest and most closely watched in the field, cut its own numbers downward in early summer as El Niño conditions were confirmed, eventually settling around 11 named storms, roughly 60% of the recent 30-year average. And by late July, the Climate Prediction Center's tropical outlook stated plainly that formation was unlikely across the Caribbean and Central Atlantic for the foreseeable future. an extraordinary thing to say in the exact stretch of summer when an average Atlantic season is normally picking up speed. The mechanism behind that suppression is wind shear. A hurricane is fundamentally a vertical structure, a column of rising, rotating air that has to stay stacked and aligned from the ocean surface up through the top of the troposphere in order to intensify. Wind shear is the difference in wind speed and direction between the bottom of that column and the top. High shear tilts the column, ventilates the heat that is supposed to be fueling the storm's core, and prevents it from ever organizing. El Niño reliably increases wind shear across the Caribbean and tropical Atlantic, one of the best documented relationships in all of atmospheric science. Private forecasting firm Atmospheric G2 identified 7 previous seasons with El Niño conditions comparable in strength to this one. And across all 7 of those seasons combined, the maximum number of hurricanes that made landfall in the United States in any single year was 1. Now look at the other side of the same continent. The Eastern Pacific hurricane season is running at its most active early pace on record, on track to potentially tie 1985 and 2015 for the second highest number of named systems ever recorded in that basin, trailing only 1992's 27 storms. In late July alone, it produced 2 simultaneous Category 5 systems. A large pool of much warmer than average water extending north toward the American west coast and west toward Hawaii, with parts of it record warm for the calendar date, is sitting directly underneath that activity. Same summer, same set of forecasters, one ocean basin effectively switched off, and the other one breaking records, and the entire divergence traces back to a shift in water temperature along the equator, thousands of miles from either coastline. That does not mean the Atlantic can be ignored, and this is the part where seasonal outlooks tend to get people hurt. A below normal season is a statement about how many storms form in total. It says nothing about whether one of them finds a specific coastline. 1992 was itself a below average Atlantic season by storm count. 1992 was also the year of Hurricane Andrew. Now to the part that reaches the most people directly, your actual winter. The atmospheric feature that matters most for North America is what happens to the Pacific jet stream, the river of fast-moving upper atmosphere air that functions as the steering current for surface storm systems. Storms do not wander freely, they ride that current. In an El Niño winter, the surge of new thunderstorm activity over the warm central Pacific pumps heat into the upper atmosphere in a place it normally doesn't reach, which strengthens the subtropical jet stream and drags the storm track southward. The Pacific jet extends further east than usual and dives across the southern half of the United States instead of making its typical landfall in the Pacific Northwest. When that pattern runs the way the textbook predicts, the southern tier of the country gets the storms. California, the Southwest, Texas, the Gulf Coast, and the Southeast, all the way up the Atlantic seaboard, tend to run wetter and cooler than normal, with more low-pressure systems moving through in sequence. The Gulf Coast and Southeast in particular carry the highest odds of flooding out of this pattern, and that is the single most consistent El Niño signal anywhere on the American map. The northern tier gets the opposite. The northern Rockies, the northern plains, the Great Lakes, the Ohio and Tennessee valleys, and most of Canada tend to run warmer and drier, because the storm track that would normally deliver their winter precipitation has been pulled hundreds of miles south. Timing matters here too. El Niño's grip on American weather is weak through the fall and strongest in deep winter, meaning the window that matters most runs roughly from December through February, with the ocean itself expected to peak somewhere between November and January. To understand what that pattern can actually cost, look at the last time a record El Niño hit, because the numbers on record are not always what people assume. The winter of 1997 to 98 was driven by an event that peaked around 75 degrees, meaningfully weaker than what is forecast for this winter. Even at that lower intensity, California had one of the wettest seasons in its recorded history, with many regions receiving roughly double their normal rainfall. Statewide flood and storm damage came to approximately $850 million. In the San Francisco Bay Area alone, landslides caused more than $150 million in damage across that winter and the following spring, and 17 people died in storm-related incidents in California specifically. At least 27 homes inside coastal zones were red-tagged, condemned as unsafe to enter. Nationally, the death toll reached 189 people, a large share of them in tornado outbreaks across the South, which is the part of that winter almost nobody outside those states remembers. An El Niño winter in the southern United States is not only a flooding story. The same southward displaced jet stream that brings the rain also brings the wind shear and atmospheric instability that fuel cool season tornado outbreaks in February, in states where people are conditioned to watch the sky in April, not midwinter. Both the 1982, 83, and 1997 to 98 events are classified in the scientific literature as extreme, and they remain the 2 best documented El Niño disasters in the modern instrumental record. This winter's forecast is nearly a full degree stronger than either of them, but that does not translate into a proportional increase in damage. The relationship between peak ocean temperature and the toll on the ground is not a straight line, and the historical comparisons available all happen to be weaker events than the one being forecast now, which loads the risk in one direction without guaranteeing any specific outcome. The impacts extend well beyond the United States, and in raw human terms they are larger. In June 2026, the Food and Agriculture Organization of the United Nations and the World Food Program issued their first ever joint anticipatory appeal, covering June 2026 through March 2027, requesting funding to reach roughly 8 million people across 22 countries, including Ethiopia, Kenya, Somalia, Sudan, Pakistan, the Philippines, Colombia, and Haiti. The money funds anticipatory action, cash transfers, drought-tolerant and flood-resistant seed distribution, livestock support, flood defenses, and water storage, all delivered before disaster strikes rather than after. That 2 agencies committed funding against a disaster that had not yet happened is itself a signal of how solid this forecast is considered inside the humanitarian sector. Their assessment estimates El Niño could push as many as 36 million additional people into hunger. The mechanism is agricultural. Drought risk rises across the Caribbean, Central America, northern Brazil, central and northern India, central and southern Africa, Indonesia, the Philippines, and Australia, while conditions turn wetter across the southern United States, parts of Peru and Ecuador, eastern Africa, the Middle East, and Central Asia. Maize and rice, 2 of the most weather-sensitive staple crops on the planet, are especially exposed. Strong El Niño events have historically weakened the southwest monsoon over India, the single most important rainfall system in the world by population dependent on it, while southern Africa typically sees reduced cereal production and palm oil output across Indonesia, and Malaysia comes under pressure. Off the coast of Peru, the anchoveta fishery built entirely on cold water upwelling thins out and scatters when the warm water arrives, which is exactly why Peruvian fishermen coined the term El Niño, meaning the boy child, centuries ago after noticing the fish disappearing around Christmas time each time the phenomenon struck. There's also a fire risk that arrives on a delay, which matters, because it means this story does not end when the ocean finally cools. The clearest fire relationship anywhere in the world tracks the Amazon, and the most severe impact tends to show up roughly a year after an El Niño develops, once accumulated drought has had time to dry out the forest. In 2016 and again in 2024, both following strong El Niño events, fires in Brazil burned more than 3 million hectares, against a 2001-2025 annual average of around 575,000 hectares, a 4-fold increase in each of those years. Applying that same lag to this event points to peak Amazon fire risk landing in the second half of 2027. A similar delayed risk applies to the peat soils of Sumatra and Kalimantan in Southeast Asia, which ignite readily once dried out and can then smolder underground for months, and to coral reefs worldwide, where prolonged heat stress causes bleaching, a genuine injury in which corals expel the algae that supply most of their food, and reefs that bleach repeatedly without sufficient recovery time between events often never fully return. There's one more global consequence, and it is the one that is likely to dominate headlines through 2027. A strong El Niño transfers a large amount of heat out of the ocean and into the atmosphere, and global average surface temperature responds typically with a lag of 3 to 5 months behind the Pacific peak. That means the ocean is expected to peak around the turn of the year, with the global temperature response following in spring and summer 2027. As of mid-August, the odds of 2026 finishing as the warmest year on record had risen sharply from around 13% at the start of July to well over a quarter, and forecasters at NOAA and Berkeley Earth now expect 2027 to take the record by an even larger margin. This is landing on top of a run in which the 11 most recent years are already the 11 warmest ever measured. Which brings us to the part that deserves an honest answer, rather than a dramatic one. How much of this is genuinely known, and how much is a model doing something it has never actually been tested on? There are 2 honest halves to that question. The first is that the confidence behind this forecast is better founded than it usually is at this point in the year. Seasonal forecasts of the tropical Pacific, issued before roughly June, suffer from what researchers call the spring predictability barrier. A real, measurable collapse in forecast skill that happens every year during the Northern Hemisphere spring, when the ocean and atmosphere sit in a transitional state, and tiny differences in starting conditions can spiral into completely different outcomes. Forecasts issued in March are notoriously unreliable. Forecasts issued after June or July are considerably better, and the International Research Institute for Climate and Society noted in its mid-July assessment that this year's predictability barrier had already passed, and that model consensus was strong. This is not a March forecast built on shaky footing. The event is already underway, already measured directly rather than projected, and the subsurface warm water needed to sustain it through the winter has been observed, not assumed. The second half is the part that gets said far less often. No forecast ensemble has ever predicted a 6-degree El Niño and then watched it verify, because no event of that magnitude has ever been observed to verify against. Model agreement is reassuring, but it is not proof. 14 models built on partly overlapping assumptions can all be wrong in the same direction at once. Tim Stockdale, a senior scientist at the European Center for Medium-Range Weather Forecasts, has written extensively about exactly this failure mode, noting that individual forecasting systems tend to be statistically overconfident, and that real outcomes can land outside the range the models offered. March of 2017 stands as one of the worst tropical Pacific forecasts on record, a reminder that this field has genuine documented blind spots. There is also a measurement subtlety worth understanding. Because the entire planet's oceans have warmed over the past century, comparing today's Pacific temperature against an older historical baseline can exaggerate how unusual the current pattern looks. Correcting for that broader warming trend using a relative index drops the probability of this event, setting an outright record from around 91% to roughly 77%. Still very likely to be a record, just not quite as overwhelming a certainty as the headline number suggests. And separate from the intensity question entirely is the impact question, which people constantly collapse into the same thing when they are not the same thing at all. A strong El Niño loads the dice. It does not throw them for you. The 2015-16 event was among the strongest ever recorded and was widely expected to end California's multi-year drought outright. Southern California ended up with a disappointing, underwhelming rain season regardless. The regional teleconnections behind these forecasts are probabilities calculated across many historical events, not guarantees for any single one. The wetter than normal odds forecast for the southern United States this winter are real, well documented, and worth planning around seriously. They will also still leave some individual communities dry, because that is how probability works when applied to a single winter rather than an average of many. So here is the accurate, honest summary. The event itself is real, and it is already underway, not a distant hypothetical. Its intensity is being forecast with unusually high confidence for this point in the year, well past the seasonal barrier that normally undermines summer forecasts. Its specific consequences in any one place are forecast with far less confidence than the intensity number alone suggests. And the gap between those two facts, the gap between we are very confident this will be historically strong and we are much less confident about what exactly happens on your street, is where every overstated El Niño headline this winter is going to live. Update on this continues on a public schedule you can track yourself. The Climate Prediction Center issues an updated diagnostic discussion on the second Thursday of every month, freely available to anyone. NOAA's full winter outlook is released in the fall. The buoy array across the tropical Pacific reports continuously in real time. If the trade winds strengthen back up over the coming weeks, the forecast will come down. If a fresh pulse of warm water moves east beneath the surface, it will go up. That is exactly what forecasters will be watching between now and the peak, which leaves the practical question of what to actually do with all of this before winter arrives. If you live anywhere along the southern half of the country, from California through Texas to Florida and up the Atlantic seaboard, the risk with your name on it this winter is water. Flood damage has never been covered under a standard homeowner's insurance policy. It requires a separate purchase, and most policies carry a 30-day waiting period before coverage actually takes effect. That means the week a storm shows up in the forecast is already too late to buy protection against it. August, not February, is the month to make that call. If you live in California specifically, check whether your property sits downslope of a recent wildfire burn scar, because scorched ground does not absorb heavy rainfall the way healthy soil does. It sheds it violently, sending mud, rock, and debris downhill. And debris flows out of burn scars have killed more people in some years than the wildfires that preceded them. County emergency management offices publish those hazard maps, and they are worth checking before the first atmospheric river arrives. If you're along the Gulf Coast or in the southeast, do not read a below normal hurricane forecast as permission to relax. Take the same precautions you would in an active season, and add winter to your planning, because a cool season tornado outbreak in February behaves differently than the storms most people there are used to preparing for, often arriving with shorter warning times, sometimes overnight. And if you're in the northern tier, the northern Rockies, the plains, or the upper Midwest, your version of this risk runs in the opposite direction. A warm, dry winter means a thin snowpack, and a thin snowpack means a longer, drier fire season the following summer and added pressure on water supplies through the year. It is a slower moving risk, easier to overlook, and one that stretches furthest into the following year. Everywhere, the baseline preparation is the same short list: several days of water and food that requires no cooking, medications refilled ahead of schedule, a way to charge a phone if the power goes out, important documents kept somewhere you can grab quickly, and one meeting point every member of the household already knows without having to be told twice. We tend to think about weather disasters as arrivals. Something forms out at sea. It approaches, it makes landfall, it passes, and afterward we count the damage. Nearly every warning system built to protect people, the watches, the warnings, the evacuation orders, is organized around that shape. But there is no landfall in this particular story. There is no cone, no track, no eye, no siren to listen for. There is only a rectangle of open ocean thousands of miles from anywhere, running well above where it should be for this point in the year. By the time most people actually feel the effects of it, it will not register as El Niño at all. It will register as a storm system stalled over Louisiana in February, as a hillside giving way onto a coastal road in Southern California, as a farmer in East Africa receiving half the rain a harvest needed, as a fishing fleet off Peru coming home light, and as fires in the Amazon still burning 14 months from now. A record El Niño is not itself a disaster. It is a reshuffling of the odds behind every disaster at once, across an entire hemisphere, and that makes it a far harder thing to see coming in the moment, but also a far easier thing to prepare for in advance, because unlike almost anything else in this category, this one has given the world nearly 6 months of advance notice before it even peaks. Incognito chats aren't saved, added to memory, or used to train models.